But let's see. Erica Fischer is an associate professor of civil and construction engineering at Oregon State University. Dr. Fisher's research interests evolve around innovative approaches to improve the resilience and robustness of structural systems affected by natural hazards and man-made hazards. As you can see, it's not just an earthquake focus, which is often the case in many structures groups. Professor Fischer has a larger view of what hazards look like. She's participated in post-earthquake reconnaissance team missions in diverse regions, including Haiti, Napa, California, Italy, etc., and also wildfire reconnaissance in the aftermath of the Camp Fire in California and the Marshall Fire in Colorado. So I don't want to take up any more of your time, Erica, so please go ahead.
Sure. Thank you so much, Ben. And I'm really excited to be here and share this with you all. So today I'm going to talk about something that is actually affecting a large swath of our nation. Just this morning, there was a fire right outside of Baltimore, Maryland. So the East Coast is really being impacted by wildfires this year, in addition to the West Coast. And so this is a study that is going to I'm going to weave a few studies together to talk about home and lot characteristics on structure survivability during a wildland-urban interface fire. And so it's kind of strange for a structural engineer to be talking about houses, but if this presentation really interests you, you should look into the Nahiri presentations. Tracy Kajewski-Korea, who's the head of STEER, is going to be giving a talk on housing in hurricanes and floods in a few weeks. So why are we talking about houses? This is actually a really interesting topic for us as structural engineers and engineers to be thinking about. When the fire is burning in the landscape, we talk about the fuel as the vegetation in the landscape, the trees, the brush, the grass. But when the fire has intruded onto the community itself, it's really the houses that are the fuel within that community. And so we're talking about houses, and we're talking about survivability of houses because in a wildfire, once the houses catch fire in a community, it changes the dynamics of the fire itself. The fire becomes more intense. Homes will release about 10 times more energy than vegetation. They will burn for substantially longer periods of time. They will create more embers that can fly up to 1.5 to 3 miles and ignite other portions of the community. And so if we can protect our homes, what we're doing is we're reducing our wildfire risk within the community because we're reducing the amount of fuel. And so there's a lot of discussion as to why we are here. How did we get here? And I'm going to give you a little bit of a history lesson as to how we got here today. And so in 1905, the U.S. Forest Service was assigned the responsibility of managing the forest reserves. The forest reserves were established in 1897 by the federal government without any agency to specifically manage the landscape for fire. As many of you know, in 1906, San Francisco burned, and after the 1906 earthquake, at this time, cities started to enact fire codes and zone and urban and fire codes, and then that reduced the urban conflagrations that we saw within our cities. In 1910, 3 million acres of land burned in the Northwest. This was deemed the big blowup. This land was across Montana and Idaho and damaged significant amounts of timber crop. For those who don't know, out here in the West Coast, specifically in the Northwest, timber is a crop. Timber is our farming that we're able to produce. And so to impact the timber crop was a huge financial loss. And so afterwards, the U.S. Forest Service received recognition for its ability to fight this fire. And up until this point in the 20th century, scientists and the U.S. Forest Service had begun to talk about how some fire can actually be beneficial to the environment. But after this event, the public became really nervous about fire, and the U.S. Forest Service began to enact policies of fire exclusion. And so what that means is that the following 3 acts were passed as a result of the fire exclusion culture and to protect timber crop. The most notable being the 10 a.m. policy, which would dictate that the fires needed to be put out by 10 a.m. the day after they are identified. During World War II, there were a number of fire prevention campaigns as the fire industrial complex grew, and the U.S. Forest Service was enlisted within the national defense programs. War surplus equipment was converted into firefighting equipment, and the development of highways through the Federal Highway Act allowed people to move into the suburbs and exurban areas. During the 1970s, there was an increase in outmigration from the cities into more rural landscapes. However, wildland-urban interface fires had started to gain more attention. In 1978, the U.S. Forest Service recanted the 10 a.m. policy, and the U.S. Department of Agriculture was authorized to assist in preventing and controlling rural fires. However, much of the wildland-urban interface communities now already existed. Places such as Paradise, California, and Bend, Oregon had begun to be developed in high-risk wildfire-prone areas. In 1986, the Wildfire Strikes Home workshop was hosted. The result of this workshop was the National Wildland-Urban Interface Initiative, and this was also the beginning of the FireWise program. In 2003, Healthy Forest Restoration Acts become law, expediting fuel reduction projects on federal lands and requiring communities to develop community wildfire protection plans to be eligible for many types of federal funding, especially grants focused on hazardous fuel reductions, among other wildfire risk reduction tactics. The act required that the U.S. Forest Service and Department of Interior allocate no less than 50% of all funding to treatments within the wildland-urban interface. And finally, in 2014, the National Cohesive Wildland Fire Management Strategy combined fires in landscapes with fire-adapted communities as a method for mitigation and places equal emphasis on both. So I'm giving you this timeline in this historical context because a lot of times the wildfire problem is solely placed on climate. And I'm trying to show to you that actually a lot of the acts that were enacted at the beginning of the 20th century and then later recanted at the end of the 20th century placed us in this moment where our communities are not mitigating. Our communities exist in high wildfire risk and wildfire prone areas, and the forests themselves that are not being mitigated because we're not allowing fires to burn. And so now you layer climate on top of this. And the dry seasons are getting longer, but also wet seasons are becoming more intense. When wet seasons are becoming more intense, we have more fuel in the forests, as well as in community open spaces. And for those who know California well, when you have that buildup of fuel that isn't managed by a dry season, there's a potential for a very intense and damaging fire, which is pretty much exactly what happened in the Marshall Fire. And so if we want to look at how to actually reduce wildfire risk or reduce risk to home loss, this has to be a three-pronged approach. Coupling land management agencies with local governments and homeowners to reduce the wildfire occurrence, reduce wildfire size and intensity, and reduce the human development in fire-prone areas, in addition to increasing the home resilience to ignition. So all these things need to happen together. We have to reduce the exposure, but also reduce the susceptibility of a home to wildfire loss. And when we're able to do that, so as I mentioned before, homes are our fuel in our communities. And if we're able to reduce the fuel, we're able to actually defend the fires themselves. So all of these characteristics that I'm going to talk to you about of homes that characteristics of homes that influence survivability in a wildfire are really characteristics that make a home defendable, right? So unless we're going to build a bunker, we're really not going to passively be able to survive a wildfire. And so when we look at fire spread within our communities, If your neighbor's home is on fire, the fire spread can occur in three different ways. The first way is home-to-home ignition. If the homes are spaced very closely together, pretty much less than 10 feet, then you can have home-to-home ignition where the ignition of one home, the flames can reach the next home and ignite the next home through radiative heat transfer. You can have ember spotting. So you have the embers kind of coming off of a structure and igniting either vegetation near the next home or igniting that next home itself. Or you can have, rather than direct flame contact, when you have home-to-home ignition, you could have it through just radiative heat transfer. So you could heat up the next home enough that the material ignites. And so the literature out there for wildfires has been a little bit backwards as it compares to earthquakes. In earthquakes, we test individual mitigation measures and we test individual components in a controlled setting in a laboratory. And then we use our real life events to test if our equations worked. In wildfires, it's been the opposite. We've gone out into the field over and over again. We've collected characteristics of homes that influence survivability. And we have then performed statistical analysis and we come up with a whole slew of characteristics. And we haven't really been testing anything in a controlled environment. And so we're really at this point right now where we're starting to do that. And so what I'm going to go through now is really that kind of breadth of literature that's out there on home characteristics in previous fires that have shown to influence survivability. And that will kind of lead into the study that we did with the Marshall Fire. And so characteristics at the house level that have shown to influence survivability have really been the eave construction, the exterior cladding, roofing material, presence of vents. So really everything about the home itself, these characteristics are to prevent fire from getting inside. So the presence of vent screens are to prevent embers from intruding. The window panes are to be able to resist fire so they don't crack and you don't get fire inside. Roofing material is so that you can have your roofing, your fire doesn't burn through your roof. And here, really what we've seen is that the characteristics differ by the density of housing. There's an increased importance on the house characteristics in moderate and high density areas where structure-to-structure ignition is more likely. So in areas where you have wildland interface communities where the homes are interspersed with vegetation in the forest, really the home characteristics are less important. And here are some of the most influential characteristics on home survivability that we've seen through all the literature that I'm listing on the screen right now. When we zoom out to the parcel itself, right? So the parcel characteristics, what this does is it reduces the fire intensity as it approaches the home itself. And so if you're able to, the whole point of defensible space is to allow the home to be defendable by firefighters. You can reduce the fire demand and the fire exposure as the fire moves towards the house, then firefighters can safely actually fight the fire itself. But if the fire is too intense on the parcel, then you're going to have to the firefighters are going to be overwhelmed with their capabilities. So all of the factors that I'm listing on the screen right here are really factors that will decrease the fire demand as it moves towards the house. And the lot size influences the importance of house and parcel level characteristics. So if you're not doing a lot of mitigation if your lot size is very large, then your house level characteristics are going to be less important. Your parcel level characteristics are going to be more important. This kind of goes back to that density of housing that I mentioned in the house characteristics. The potential for defensive action is really driven by what mitigation has occurred on the parcel itself. Now, if we zoom out even more, we can start looking at neighborhood characteristics. This includes present, is your home located on a cul-de-sac? The reason this can be important is because firefighters can get trapped and they can't get out. The same with, isolated communities. Housing density is going to be a huge factor in your neighborhood characteristics because it's going to tell you, how close your homes are to each other, and if your lot characteristics or your home characteristics are more important. Um, and so, just as you might expect in low density neighborhoods, wildland fuels drive the fire spread. But as the density of houses becomes, increased, we see that homes become the primary mechanism for the fire spread. And so we're really looking at, defensible space and restricted means of ingress and egress in order to fight the fires themselves. And so what we really wanted to understand with the Marshall Fire is we wanted to be able to identify some of these factors that impact house survival, considering the effect of differences in building practices, wildland-urban interface zone classifications, and across different impacted jurisdictions. So for those who don't know, the Marshall Fire occurred on December 30th, 2021. That's right, it was December in Colorado. The fire started as a grass fire and through hurricane force winds traveled towards the communities of Louisville, Superior, and unincorporated Boulder County. The fire began to be contained on December 31st, 2021, when it started to snow. Over 1,000 homes were destroyed, about 150 were damaged across these 3 different jurisdictions. Just as all hazards, the hazards don't know jurisdictional boundaries. And so this gives us a really rich data set to look at how building practices might change across these jurisdictions. Because Colorado is a home rule state where laws are passed locally and building codes are adopted locally. So I co-led the Geotech Extreme Event Reconnaissance team that investigated the Marshall Fire. If you're really interested in the report, it's quite long, and here's a QR code for you to scan it, and I'm happy to send Ben the link as well so he can distribute that out to everyone. And so we investigated more than just houses with the GEAR team, but I'm only going to focus on that right now. We performed in-field surveys and then also had remote data collection. So we were looking at multiple modes of data collection. We looked at characteristics across housing, parcel, and neighborhood. So just as I was talking before about all of these different characteristics, we really wanted to see which ones influenced more in these types of neighborhoods. And they were, Louisville and Superior were very similar types of towns, but unincorporated Boulder County had large plots of land, very large homes, and so in parts of it were actually a wildland-urban interface community, rather a wildland-urban, or it was a wildland-urban interface community and wildland-urban intermix community. And so we really wanted to see how that affected the factors that influence survivability. So to give you an idea of what these homes looked like, the vast majority of them had porches and decks and wood frame construction. A lot of them had fire-resistant roofs because in 2008 there was a hailstorm, and it damaged a lot of the roofs, and a lot of people replaced their roofs after that. And modern material just tends to be more fire-resistant. We saw the story of this is really wooden fences on the parcels. Everyone had wooden fences. And the reason why this was important is because when you have a wooden fence that touches one home, if it is on fire, that wooden fence becomes a conduit to ignite the next home. So we saw a lot of fire spread due to these wooden fences. We also saw a lot of parcels bordering open spaces, and the open spaces burned in this fire, and the open spaces were overgrown with invasive vegetation. There were actually controlled burns scheduled for April of 2022, and the fire occurred December of 2021. So it was recognized that these open spaces were a threat, and they just hadn't gotten around to dealing with it yet. We saw mostly modern construction, and this is really important to note because modern construction materials tend to be more fire resistant. It also just means, it just also indicates a certain level of care to one's home. We are not dealing with homes that maybe don't meet modern building code requirements. All these homes were quite new. And we also saw that our homes were spaced very closely together. So you can really see the difference here between Louisville Superior and unincorporated Boulder County, where the mean distance to the nearest house is about 13 to 15 feet in Louisville and Superior, and then 140 feet in unincorporated Boulder County. So much larger lot sizes in unincorporated Boulder County, much larger spaces between the homes. And that tells us about the fire spread within the community and the mechanism in which it spread. And so we took all these characteristics and we analyzed it using a random forest machine learning algorithm, which utilizes combined classification regression trees to reach a single predicted outcome. To accomplish this, a training data set is repeatedly bootstrapped or randomly sampled with replacement with a regression tree generated for each bootstrap sample. We made sure that a minimum of 1% of the data was contained in each branch of the trees generated. And for optimal performance of the models, the training data sets were 50 to 80% of the provided data set. And the training data set was used to generate each of the trees. And so this is just an example tree that might be generated. And so this algorithm is actually really helpful in helping us determine which characteristics are most important in housing survivability, rather than developing some sort of regression equation, because not all parameters are included in predicting the survivability of every single home. In terms of our accuracy, the vast majority of our homes that were in the data set were destroyed homes. So our accuracy of standing homes is a little bit lower, but our accuracy of predicting destroyed homes was quite high across all three jurisdictions. And so something that random forest analysis generates is what I'm showing on the screen here. This is the % increase in mean square error if one of each of these variables was removed from the model. So it gives us a level of importance in the model. And so the different shading that you see vertically is just arbitrarily assigned by us. We are just trying to group, like least important or moderately important and then very important. And so we analyze the data individually by jurisdiction and then across all jurisdictions. A lot of previous literature has analyzed across all jurisdictions, and what that can do is it can kind of smear out what the impact of building construction methods are for that jurisdiction or adopted building codes. And so we really wanted to be able to see if we looked at all jurisdictions, do we see the same thing if we look at each individual one separately? And so for Louisville, what we saw is that neighborhood housing density was quite important, followed by elevation above sea level, construction year, the location of the house itself, lot size. I realize these are very small, and I'll pull some of the factors out in a few slides. Louisville and Superior are very similar towns, but even just between these two, we saw different factors showing up in the importance of the factors within our models. And then we see something completely different when we look at unincorporated Boulder County, which is something we sort of expected given the difference in the housing characteristics. All the data combined skews more towards Louisville and Superior, and that's because most of the homes destroyed were in Louisville and Superior. And so really what this is showing us is that, dividing out the data by jurisdiction allows us to really see and catch those nuances of the jurisdiction itself. And so what I'm showing on the screen are the top 5 most important variables or factors in each of the models that we had. I'm going to walk through this just a little bit. And so all of them had elevation above sea level. And elevation really influences fire dynamics within a community. Fire moves very quickly uphill. And so the elevation above the sea level is quite important in predicting the fire dynamics within the community. Distance to nearest destroyed home, or distance to nearest neighboring house, it came up for Superior. And in the aggregated data, something similar came up in Louisville with neighborhood housing density. And so, this housing density was really important when the homes were spaced very closely together. Latitude and longitude can be a proxy for many different things. Unfortunately, in the United States, we don't get data on where firefighters were in an urban conflagration. We know where they are in the wildland. They have trackers on them for safety, but when the fire is in the community itself, we aren't able to track firefighters. So latitude and longitude could be a proxy for where the firefighters were during the fire. It could also be a proxy for wind. And so in this fire particularly, the wind shifted direction halfway through the fire. Originally, it was going east to west, and then halfway through the fire, it shifted to north to south. And so we were trying to capture that within our model. And latitude and longitude allowed us to actually try to capture, where that wind direction, and if that was important, the location of the house itself. Only in unincorporated Boulder County did wooden fence touching the house show up. That's because 99% of the homes in Louisville and Superior that were destroyed had wooden fences touching the house. So it just didn't show up in the model. And then lastly, located in an isolated community, this really speaks to firefighter safety and the ability to defend the community itself. When the home is located in these isolated communities or in a cul-de-sac, and all the homes are ignited, this creates very unsafe conditions for firefighters, and they have to leave. They have to abandon the community and stop fighting the fire there. So some of our conclusions that we had is that actually housing arrangement within communities was really influential on predicting home survivability for the Marshall Fire. That when we aggregated the data across the jurisdictions, we can overlook some predictors that influence home survivability that might be jurisdictionally specific. We also ran pre-fire predictors only. And so we only ran the model with factors that we would have known before the fire. And so we actually saw that those factors were really critical in predicting home survivability. And lastly, one of the points I wanted to point out is that really a lot of the factors that I'm showing on the screen here are not within the homeowner's control. And so for these types of communities that are more interface communities, where they're more suburban communities, the layout of the community and the arrangement of houses within the community are really critical to survivability. And this is not within the homeowner's control at all. And so, again, we're talking about houses, and this, I want you all to like take away something bigger from this presentation. It's not just about saving houses. Our homes are our assets within our communities, but our homes are also our fuel, and they're exposing the rest of our critical infrastructure to these large fire demands. When homes catch fire and intensify the fire itself, we are putting our hospitals, our schools, and our utilities at risk to some damage in a wildfire. And I'm going to give you a little bit of a short story before I wrap up. in that I do a lot of research on water infrastructure and in wildfires. And what I want to highlight here is that when homes are on fire, they're heating up everything around it. And in the West Coast, we use plastic service lines to connect our homes to our water meters and our main service laterals. And so when our homes are burning and they're heating up our plastic service lines can thermally degrade, releasing volatile organic compounds into the water distribution system. In addition, when our home completely burns down, we have an open interface between the water distribution system and the air itself. So and it's spewing water. And so you have these tiny little pipes that are just leaking water and causing a lot of demand on the system. When firefighters hook up their hose to fire hydrants down the street, often they find they have no pressure. And so they can't pull water from it. Or if they do pull water from it, they are actually depressurizing the entire system, sucking ash and soot in through those exposed pipes from the burned down homes. That ash and soot also contains volatile organic compounds. Everything I'm saying here has actually occurred. It happened in Paradise in 2018 in the Camp Fire. It happened in the Tubbs Fire in 2017 in Santa Rosa, California. Happened all over the state of Oregon in 13 water districts during the 2020 fires here. And it continues to happen in Oregon as well as in California. And so, it's all because the homes are burning, right? So, something that I want you to take away from is, when we're trying to mitigate our homes, we're really trying to de-intensify the fire to allow this fire to be defendable in a successful way. So we don't expose our critical infrastructure to this massive fire demand. We're not losing assets within the community, and people can come back. And so just some acknowledgements is the graduate student working on the project, Amy Metz, some undergraduate students that helped us out here at Oregon State University, as well as CU Boulder, one of my collaborators that I've worked on with this project, Abby Lyle, and this work was funded both by the Alfred P. Sloan Foundation as well as the National Science Foundation. And I'm happy to answer any questions.
Great, Erica, thank you for sharing all this. I know so little about this topic that it's really neat to see all the work you've done on it. I guess, yeah.
Something a little different for Friday morning.
Yeah, for sure. I think it's really exciting to see something different than what I'm used to. But let's see, if people have questions, I'd encourage you to maybe use the chat or the raise your hand feature maybe, so we can keep things in order. And maybe while people are thinking about that and finding buttons, I wanted to ask were there any factors in your study that you expected to be important that ended up not having a big effect? Or like, I don't know, things that people talk about that, oh, I'm going to do this to my house because this is known to be a good thing, and then maybe it doesn't have a big effect?
Yeah, there was a lot of vegetation on properties. Most of these properties, I would say none of the properties had been mitigated with their vegetation. So there was a lot of bark mulch next to homes, which is highly combustible. I should preface that. Not everyone knows that. A lot of like vegetation touching the home, a lot of vegetation overhanging the home, and we thought that would show up more as a factor that influenced survivability. But really it didn't show up at all.
Hmm.
It's not to say it isn't important in some communities. It wasn't important in this community.
Yeah, is that maybe because the houses themselves are more fuel than just a little bit of mulch around it? Or I don't know. Interesting.
The homes were spaced so close together that the fire spread mechanism was really direct flame contact. So it didn't matter what vegetation was on your lot. The fire was going to ignite your home if your neighbor's home was on fire. It's really, yeah.
Neat. Anyone else want to jump in? Yeah, Lauren, go ahead.
Uh-oh.
Sorry.
Sorry. Hey, Erica.
Hey.
I did have one question related to home ignition. So I remember when we were in Philly, they were looking at like impact of mitigation techniques on home ignition. And I was curious if you've learned any more about that, and given the issue with proximity, if that do you think could make a difference with mitigation strategies?
Yeah, so there's um uh mitigation strategies that can help with home ignition is our window treatments. And so like making sure it's all about like, right, it's preventing the fire from getting inside the next house. So treatments on the windows so the windows don't break or crack. Uh the siding, the specific siding that's on the house itself, maybe like some roofing material. When the homes, a lot of what has kind of come out of IBHS and NIST and Underwriters Laboratory is that when homes are spaced this close together, kind of like 10 to 15 feet, there's very little that you can do to prevent home-to-home ignition. You can delay it, but because and so there's like a number of reasons why. One is that just like when a home is burning, it's releasing a lot of energy. And all of that is being radiated right onto the neighboring home. And so there's very few materials that will just like maintain for hours on end as a home burns. The second reason is because a firefighter is not going to go in between that house to prevent the home-to-home ignition because it's not safe for them to be there. So so again, like a lot of the mitigation strategies are really to make your home defendable. And so like a lot of what communities are looking at now is like if you do have homes, I mean, right, our communities exist, so we have to do something. So if you do have homes that are spaced that close together, are there ways in which you can basically prevent any ignition within that neighborhood or that subdivision? So they have to be more stringent with their vegetation. They have to be more stringent with their home hardening to prevent any ignition. And so because once one home ignites, it's kind of like game over with the rest of them. Yeah,
Thanks.
Lauren's working with me on the water project. She got to know a lot about fire.
It's been fun.
Neat. Yeah, Gaiji, you want to jump in? Yeah, and sorry about not letting you unmute earlier, Lauren. We're all waiting for you, and it was it was our fault.
Uh-oh.
Oh, it's happening again. 1 second. All right, trying to
Okay.
work it out. I don't think.
Yeah, thank you.
Right.
Yeah, thank you for your great talk. As you mentioned about the amber, I actually very curious how to simulate the dynamic of the amber like with wind. And also I'm curious about the ignition criterions. So how you define the, the criterions for that?
Yeah, so Ember modeling is quite complicated. Usually it's modeled stochastically. And so there's a few professors around the country who actually simulate Ember propagation in the community. and how to incorporate that into their fire spread models. There's a few fire spread models that are kind of more commercially available that kind of like incorporate a certain percentage of ember propagation just kind of smeared across the model to incorporate it in some sort of way, but it's not like directly explicitly modeled. Most so you ask a good question of like how to, you know, so fire spread modeling within communities. So if I'm going to model the fire spread within a let's say I wanted to model the Marshall Fire. Let's just say that one. The models, none of the models out there are actually physics-based models. It's all modeled through a coupling of GIS. So basically the fire propagates one, you know, square in the mesh of the community. And then if all the neighboring meshes, you know, ignite depending upon the ignition potential of the vegetation that you put there. We're not, you know, there's very few models that are out there that are modeling fire spread through a community, actually considering ignition through, you know, heat flux values. That's like, first of all, and then secondly, there is actually zero data on this planet to validate any of those models. And so we are able to kind of obtain satellite imagery of where the fire was at certain times. We, you know, kind of crowdsource that data. But satellites only take images every 12 hours, and some of these fires only last for 12 hours. So the Alameda fire in Southern Oregon, the whole thing took 12 hours. So, you know, maybe you get like one satellite photo, and that's it. So this is, you know, those of you who do remote sensing, and that's why I, you know, work with Lauren, these like censoring a community, to obtain actual data on wildfire propagation through a community is desperately needed. But there is data on like how different materials will ignite or vegetation will ignite depending on the heat flux it's exposed to. And that's how we quantify, you know, the ignition. Hopefully that answered your question.
Yeah, neat. Pedram, do you want to jump in? I think you should be able to unmute. Thank
Yes,
you, Mary,
yes.
for
Yeah,
saying that.
I checked it along the way too. Hi, Erica. Good to see you again, and
Yeah.
a fantastic talk. I have a quick question about, like Ben said, I also know little about fire, so it's very interesting to see your work. In terms of damage levels and damage assessment, like for example, as you well know in earthquake engineering, we say, you know, 1% is this much damage and 2%, and we keep going with like drift as a measure of performance as an index, and then based on that drift or that damage, we know how much work we would have to do to bring the structure back. Do you guys have like a certain index in fire as well? I'm sure you do, but I wonder what that is and how you assess that.
Yeah, we actually don't.
Oh, you don't? Okay.
I feel like all of you are gonna
So
walk away with like it's like the Wild West out here. Yeah, there's a lot. So I mean, I will say like a lot of these issues is because civil engineers are just starting to work in the fire realm. So I started working in wildfires in 2019 after the 2018 Camp Fire. And like I was one of the first civil engineers in the country doing wildfire work. So this is very new in civil engineering. And so there's a lot, right? There's a lot to do. And so we actually don't quantify the demand at all. And a lot of that is because we don't have the data to quantify the demand at all.
Right. So it's almost right now it's the 0 and 1 kind of whether you're affected or not affected. Got it.
Yeah, and in terms of like your house, it's kind of like that anyways. So it's very binary. You're either destroyed or you're standing. And even if you have like substantial smoke damage, you might be deemed a total loss by your insurance anyways. So it's very binary when it comes to fires. anyways.
That makes sense. Yeah, thanks a lot for the
Yeah.
explanation.
Yeah. Lauren, you want to jump in again, or is this the?
Sorry, I have another question, and it kind of follows what Pedram was asking. I know you had done some work with like hospitals and other things and schools, and those are more engineered structures than your typical home. And so I was curious if you've seen a difference in fire response of some of these more highly engineered structures, or does it follow the same thing, like once it ignites, you're kind of done? Or I don't know if that question kind of made sense.
It does make sense. You know, once the fire, it's like the same concepts as homes, right? You're trying to prevent the fire from getting inside of the building. So your cladding, your roofing, your vent covers, your windows are all really critical in preventing the fire from getting into the building itself. You know, these types of buildings are like highly sprinklered in an effort to reduce the fire demand within a building or prevent the fire from getting to that post flashover phase to begin with. But yeah, it's I think what's different is like what we found with schools was the layout of the grounds was like very instrumental in determining the impact on the building. And so schools can oftentimes have they're kind of like in the middle of their property and they're surrounded by playing fields and parking lots, all things that don't have a lot of fuel. And so they naturally have these like fire breaks all around them, which we like, it's not on purpose, right? But we were seeing over and over again that it was actually quite helpful in preventing fire intrusion and in reducing the demand of the fire as it encroached on the building.
Thanks.
Neat. Getson, you want to jump in?
Yes, can you hear me?
Yeah.
Yes.
Yeah, I just have one question, which is also similar to the question that Pedram asked, which is related to the exposure and how you treat, let's say, the influence of climate change or the changing frequency of the fires over time in the models that you use to predict if you have a total destruction or not of the house. How you include this information?
Yeah, that's a good question. So we can adjust the saturation and of the vegetation. So the way that we do it is by adjusting the moisture content of the vegetation that's like that are surrounding the community as well as in the community itself. And so we're able to do that as well as you can adjust. I mean, there's a whole weather side of this that I haven't talked about at all. And so there's when we actually simulate fire propagation through a community, part of the simulation is an input of weather data. And so that's where that can be captured. Another part is the input of fuels data, not just homes, but all of the vegetative fuels. And so being able to simulate that within a community and the right moisture content of those fuels.
Thank you.
Neat. We might have time for one last question, maybe. Does anyone else want to jump in? Because if not, I was also wondering, have policies been changing since these big fires? Like I'm just curious, has anything been implemented since, or are we still trying to just grapple with what kinds of policies would actually help, given that what you mentioned at the very beginning of your talk, all the fire suppression policies 100 years ago have actually caused problems nowadays. Like, what has anything changed recently?
Yeah, there's been a lot. So locally, in Oregon, we passed Senate Bill 762 in 2021, summer 2021. So we mapped wildfire risk throughout our state. We defined what we would define as the wildland-urban interface. We created funds for people to mitigate their homes. The funds are more available to socially vulnerable populations. In California, they have done quite a bit with their mitigation, but also they're having CAL FIRE map where all the isolated communities are in cul-de-sacs. So as I mentioned, like in my presentation, this was like an issue in the Marshall Fire. They're actually mapping that and identifying it in the state. There was a lot passed in the state of Washington that around wildfires. They are very binary in their determination of the wildland-urban interface and requiring mitigation whether you're in or you're out. Whereas in Oregon, we have different buckets of risk from low to high, and we're only requiring mitigation in moderate, high, and very high communities. There were three committees at the federal level under the executive branch of the government that were formed. One created a whole document of priorities for the government as it pertained to wildfire and wildfire mitigation. One of those priorities was actually to define and put forth basically a NEHRP for wildfires, which was like really interesting. So yeah, there's like a lot going on, a lot locally, a lot federally, and I mean, there's kind of this kind of tension between the U.S. Forest Service and FEMA, like who has jurisdiction where. FEMA has kind of gone back and forth on prescribed burns over the last 5 years, and so there's a lot of movement and there's a lot happening. But you know, it is also like, you know, we're in the first 5 years, so it's also kind of trying to figure out what's most effective.
Yeah. Neat. Yeah, well, thank you for sharing all this with us. As I told you before, I know very little about it, and so it's exciting to learn about these new topics as they emerge. And I know you have a busy rest of your day, so I don't want to take any more time if you got to rush to something else. But yeah, thank you everyone for joining us. And yeah, see you all in the next seminar. And I'll see you in a month, Erica.
All right. Bye.